Good afternoon and good morning, good evening to everyone. It's a pleasure to be with you today. Um, Carol and I will be going over from software to ConOps, from software ConOps to ROM in 6 easy steps. Carol, did you want to say anything before we get started?
Just that the awards I got were actually in 2022. The software cost estimating Educator of the Year was in 2022, and that was for the work in the presentation that Ashley Harold did last week on the software cost estimating body of knowledge. I was the lead author for that initiative. Harold and Dan and a number of other people were on the team and contributed, and it was an interesting experiment and a very interesting project that culminated in our software cost estimation certification. So if anybody is listening in and is interested in software cost estimation, take a look at that ICEAA body of knowledge, which is available at ICEAA.org. And Dan and I have been participating in that for more years than we probably care to mention. So, Dan, I'm going to have you kind of start this off if I can forward the slides properly. Let's see.
Sounds good. You can skip our intro slides. Paula gave us a nice intro. There we go. All right, great. Thanks, Carol. Uh, so today we'll talk about the primary software development cost drivers, which, as most of you are probably aware, are software size, which is driven by the requirements, as well as productivity, how well a team can develop the software. Then we'll go over the process of creating a ROM based on early high-level functional requirements. And in this particular case, we're talking about a concept or operations document or a ConOps. We'll go through the 6 steps, then I'll turn it over to Carol, and she'll go through the case study that was taken from the CEBoK-S, and then we'll have some concluding remarks. Just a note, this is a shorter version of the presentation that Carol and I did in May at the ICEAA conference. So we took out a lot of the background information, but if you're interested in that, you can just email Carol or I, and we can go ahead and send you the full version. Next one, please, Carol.
It may actually be in the presentation that we put together. And one of the things that I just want to mention that some people who are new to software cost estimation may overlook, we're looking purely, when you've got a concept of operations document, which Dan is going to talk about in a minute, when you've got something like that, it's going to contain system requirements, it's going to contain maintenance requirements, it's going to contain all sorts of additional requirements. We're purely looking for this particular presentation from the software ConOps to creating a high-level ROM for the software development piece. Not all these other pieces, not all the integration, not all the other putting it onto hardware, but purely the software development piece. And I think that's really important because oftentimes estimates become wrong, not because they weren't done properly, but because they didn't include things that people assumed would be included. So I just wanted to put a little boundary around that.
Yes, that's a very good point. Thank you, Carol. All right, so as we mentioned, the 2 primary drivers, as is noted in the CEBoK-S for software development are, of course, the software size, regardless of what sizing methodology that you're talking about. In this particular case, we're talking about IFPUG simple function points. And they are key cost driver, and they can be a physical size like slot, functional and non-functional size like IFPUG function points and snap points, and then relative effort size or other sizing methods. And then, of course, the productivity side is how fast can a team or a person develop software? And there tends to be a nonlinear relationship between size and productivity, meaning as a project gets larger, the productivity of the overall team will drop. As a matter of fact, I think there's a point at Capers Jones said that once a project gets to a certain size, it's almost doomed to failure. And again, it's based on the complexity of the software, what the development team's capabilities are, and your schedule. Do you have any constraints on your schedule? Do you have to compress things? And then if you're familiar with the impossible area, there may be areas where you can't compress it anymore. So you might have to de-scope. Next slide, please, Carol. So here's an overall view of the steps. First, you start off with your step 0, which is the concept of operations. We'll talk a little bit more about that in a second. And then once you've done that, you go through the standard IFPUG sizing methods, starting with the identification of your software boundary, and then your functional user requirements. As Carol mentioned, we're only talking about functional user requirements. I'm going to measure those with simple function points. Then we size the logical files, which is the equivalent of an ILF or an EIF in IFPUG standard function points. Then you want to size your elementary processes, otherwise in standard function points known as your external inputs, your external outputs, and your external queries. Then you want to check your historical data. Now, you may be able to have access to local data that you have, enterprise data that would probably be best if you had. But if not, you can certainly use something like ICEBoK-S data to come up with that historical productivity data that you can use to compare and develop an analogy estimate to the project that you are estimating. And then developing your ROM for your effort, cost, and schedule based on that analogy. Next slide, please. So what is a ConOps? I think most of us are probably familiar with it, but it's basically a high-level conceptual description of the way the system that you're estimating operates. It can be very, very high level and just give you the main features of the system. Oftentimes they'll talk about the as-is and to-be state of the system. And but it should give you a high-level functional description of the requirements that you'll need to size in order to develop your estimate. Next slide, please.
Sometimes people will use Apex for this same type of thing.
Yeah, especially in Agile. This is probably something that you all are very familiar with. This is when we're talking about estimating at the ConOps phase, we're at the very far left of the cone of uncertainty. And you know, a lot of people don't realize that with the cone of uncertainty, if you look at the top part of it, you can be underestimating by 4 times or overestimating by 0.25. So there's a big variance, but most estimators, for a variety of reasons, tend to more likely underestimate a project than overestimate it. And then again, looking at best estimating methods, depending on where you are in the software development lifecycle. Given that we are at the ConOps level, we're very early in the program. Analogy is an excellent method to come up with a ROM estimate. So those both fit into where we are as far as developing an estimate using the ConOps. Next slide, please. So the first thing we do, we identify our software boundary. For those of you who are familiar with function points, that is the conceptual line that the interface between the user and the system. Data has to pass through that and come back out of it to be counted as an elementary process. And it has to be stored to be counted as a logical file. And it's very important that you properly set your boundary. If you do not, you run the serious risk of possibly over or undercounting the system that you're estimating. And there could be a case in your ConOps where you have multiple software systems being sized, and you want to do a separate size estimate for each piece of that if you have multiple application boundaries. Next one, please. So what are software functional user requirements or FURs? They're a subset of the requirements that describe what a software system does. It's the action part of your system. What data does it store? What kinds of capabilities does it give your users as far as interfaces with other systems? And of course, when we're talking about function points, when we talk about users, a user can be a person using the system, or it can be another system. So we're talking about interfaces, things like that. The data that's stored and referenced, whether it be within your application boundary or another system. And typical functional requirements handle things such as data processing for described, create, read, update, delete. If you're doing batch files, putting data entry in there. And in business processes, if you're approving things, making payments, disbursements, etc. But they're inputs from and outputs to the users, the primary thing. They do exclude our non-functional and technical requirements that Carol was talking about earlier. We're strictly focused on our functional requirements. So this is a typical function point diagram if you're using your standard IFPUG 4.3.1 Accounting Practices Manual rule set. Now, what simple function points does is, rather than having to worry about identifying which type of elementary process is doing what kind of functions and all that, and at the ConOps level, you probably don't even know how exactly all those functionality features are going to be implemented. So it strips it down to two pieces. So rather than having three external functions or transactional functions, we have one, an elementary process. And instead of having two different types of data stores, our internal logical file or external interface file, we have one logical file. An elementary process is 4.6 simple function points, and a logical file is 7 simple function points. So it does allow you, even if you have more detailed requirements, to do a much quicker count because you don't have to make all those distinctions. Next one, please. All right, so the first thing we want to do, generally speaking, is identify our data and size all of our logical files. Again, each one, whether it is an internal or external, using simple function points, is 7 simple function points. And then we go on to identify the transactional functions, or the elementary processes, that are maintaining the data or referencing the data that we have identified in step 3. And then this is where your historical data comes in. Now, if you have, preferably you'll have sort of in-house historical data for your teams that you can use to compare when you're doing the analogy. But if you don't, again, you can use commercial tools, or you can use something like IFPUG data, which is a great way to find data for analogous projects. But a couple things to point out: you got to make sure that you make adjustments for the project you're estimating as compared to the project or projects you're using for your analogous estimate, and adjust accordingly. You just don't take the data and say, okay, that's good, they're the same size, that's it. You have to look at other factors, team experience, and help to normalize that data to make sure that you're getting the closest ROM estimate you can based on that historical data. So then once you have that, you can go ahead using SIRS or cost estimating relationships to develop an effort, cost, and schedule for your ROM estimate. So what you want to do when you're doing an analogy estimate is, of course, to find similar projects. You want to make sure they are similar platforms, similar types of systems, preferably similar languages, and complexity. Developer capabilities, you want to make sure, if you're doing an analysis project for a team that's new, you don't want to compare those to projects that were done by very experienced development teams. You can, but you want to make sure you adjust accordingly. And if you have a situation where you have a compressed schedule, you have to meet a certain deadline, you want to make sure that one, it is feasible, and two, that you can find similarly compressed scheduled projects. Again, we talked about some of the data sources here. The SRDRs are very good if you have access to U.S. government data. Again, IFPUG is pretty much the gold standard as far as I'm concerned. And then you have other commercial tools that you can use, such as CRSM, True Planning, SLIM, etc. Next slide, please. So again, you want to make sure that you are adjusting your scope to your historical data, and that they include the end-to-end, if appropriate, phases of the software development lifecycle. So if you're going to do the full life cycle, you want to make sure that your historical data is for the full life cycle. If you're just doing design, code, test, and integration, you might want to make sure you got to make sure that you find the right data set that matches that phase of the life cycle. So then, once you've gathered your data, you sized your project, and you found the appropriate analogies, we can use these CERs, the cost estimating relationships and schedule estimating relationships, to develop our cost and effort and schedule. So you take your estimated functional size, you multiply that by your historical effort, and divide that by your historical functional size to get your hours. With cost, again, you're using your estimated hours times the labor rate or rates. You might have multiple rates or a blended rate. Divided by the number of hours. And then you've got your estimated schedule is the number of hours divided by your hours per person month and your team size. Typically, default hours per person month is generally used at 152, but you can use 160 if you're estimating for a system that's going to be developed by contractors who won't be billing you for things like personal time off or something like vacation, sick time. So once you've developed those, once you've evaluated those formulas and come up with your ROM estimate, it's not a bad idea to go ahead and double check against some kind of tool like the Kokomo tool, Kokomo 2, SEER, or other tools to validate that your ROM estimate is in the ballpark. You want to be within 10 or 20%. That's a good estimating practice, just to give you some more defensibility and support of your ROM estimate when you generate it. And that, I think, is the... So now I'll turn it over to Carol, and she'll go through the case study.
And this is, as Dan said, we've presented this many times before. We've always had 45 minutes to an hour at least, so we've excluded a lot of the slides and a lot of the preamble, but it may be included in the... I know that when we submitted our slides, there's ones that come up if you look at the presentation. So we put this together into a ConOps case study to kind of illustrate what Dan's been talking about. And a rough order of magnitude is something like a manager comes to you and says, look, we've got this ConOps, or we've got these epics. We need to know, is this going to be within our budget, or is it going to be like 50 times what it is? And when you're talking to major government organizations, they want to know something fast, dirty, simple, that is data founded. And that's really important. That's one of the things that I learned from doing the software cost estimating body of knowledge and working with a team of absolutely top-notch, world-class software cost estimators, is that if you're going to develop an estimate, make sure it is data founded and that you do a cross-check. It's like I used to say, anything that's important, you want to get a second opinion. If you go to a doctor and the doctor says, you know, Carol, I think you've got cancer, I'm not just going to go, oh my gosh, okay, whatever. I'm going to go and get a second opinion. The same thing with any estimates that we're doing. We want to make sure that we do a data founded, not just expert opinion, not just, oh, I kind of sort of think. That's why our estimates get in so much trouble. That's why we're at such a low level of estimating maturity, which also was defined in the software cost estimation body of knowledge, and you can see it in Harold's presentation from last week. So we took a look and we said, you know what, let's take the course registration system, which actually was is something that Elena Brown uses in the COBEC presentations. I used it in a book in 2008, and we've used it again in the software cost estimating body of knowledge. So it's a little course registration system. We've got a little use case diagram. Usually ConOps, even at a very high level, is going to identify what are the use cases, what are the types of things that this piece of software is going to be able to do. So this is the example, and the first step really is to say, what is our development scope? What's the scope of what we're going to be doing? We're going to be doing an end-to-end development, starting with requirements, going through to delivering the software. And so we've got in the same software boundary, we've got this login process, and we've got these different use cases. Always people are outside the software. So that's why we've got these actors or these little in our object model, that those are outside. So we've identified here that there's one software boundary. So then we're going to have one functional size that we're going to develop. So if you take a look at the use cases, there were 8 different use cases. We can go through and say, okay, what are the functional user requirements? And functional user requirements, as you know, anybody that has been in functional size knows that functional requirements answer the question, what will the software do? Not how is it going to do it, not how robust, not any of those ilities, but what does the software do? Now, these are pretty clean, they're really simple, but we could have had something that says log on by all users quickly. The quickly part tells me how. That is not part of my functional user requirements. So these 8 are my functional user requirements. Note that manual or non-functional requirements could also be in my ConOps or in my epics, but they're not going to be included in what I'm sizing. So the next thing we do is we size the logical files, anything about which we know that we're going to be storing data. So logging on, we know there's got to be users somewhere that we're validating against. So we've got a user logical file. We're going to maintain professor information. So we know that we've got to be storing information about a professor. We've got course catalogs, student information, course registration, register. Going through this, we can very quickly say, you know what, there's probably about 5 logical files, each worth 7 simple function points. That gives us 35 simple function points. Next step is to go through and say, what do we have in terms of elementary processes or units of work, self-contained sets of requirements? So log on, that's one. Maintain professor, we've decoded that and said, you know what, when we talk about maintenance or maintaining, we think of create, read, update, and delete. In other words, a CRUD in the vernacular of software developers. So a CRUD is 4 separate elementary processes. We go through and we end up with, you know what, it's about 14 elementary processes, each worth 4.6. We end up with about 65 simple function points total. We're sitting at about 100 simple function points. So what do? We then go and say, okay, where can we find some historical analogous data that would be similar? Well, we don't have any, so we're actually going to go and illustrate using the IFPUG database. And once we've got a similar project that we can compare to, then we're going to generate based on a linear representation between the project that we think is similar and the one that we're looking at. The reason that we want to make sure that we've got similar projects is that diseconomy of scale, the fact that we've got an S curve between small projects and large projects and their effort and cost, is that, again, it's a relationship between larger projects are going to cost more than, if I double the size of a project, it is going to more than double the effort due to different things that are going on in terms of project management, communication, and managing those projects. So in lieu of historical data, we're going to take a look at the development and enhancement repository. I don't have access to the 2020 or 2021 or even the 2023 set of data because you have to purchase that from IFPUG. So I did have access to a 2007 version of example data. So we pulled in and we said, okay, let's just look at the data quality rating of A or B, so top quality. We're going to look at a size range between, say, 75 and 200 function points. Remember, our project we're looking at is 100. Industry sector, development type, we're only going to look at new development. We're going to look at IFPUG 4 and higher. We could use additional filters if we ended up with too many projects coming back. So, as I mentioned, software development end-to-end, we're going to start with requirements, end with the software quality testing, and we're going to compare that to what we find in IFPUGs. We found a couple of example projects that could match it, so we're going to further refine them to find the most analogous project. We found 2 of these, and we could go and do some parametric regression on those, but we said, you know what, let's just use these. So we identify the applicable hours by using this analogous representation where the simple function point size times the IFPUG's analogy effort that we found divided by the IFPUG's analogy size. So we've generated and we've come up with 2446 person hours. which if we're using 152 is 16 person months. We'll estimate the cost by taking that number and multiplying it by just a nominal 60 US dollars per hour. And we can end up with the estimated schedule, which is the duration. We're not talking about a Gantt chart schedule. We're talking about duration when we talk about schedule. So it ends up being about 9 months. So we're not going to stop there. We also want to take a cross check. Again, I said we need a second opinion. So this is a really excellent, absolutely free website that you may want to go to. It's created by Ray Madachi, who was part of the Naval Postgraduate School. He was always been part of the Kokomo 2 and the Kokomo 3 development out of the Beam CSSE in the University of Southern California. And Ray maintains this web tool. He asked me to include his email here, so if you've got any problems with it, but you can go and use this anytime you want. So we put in the assumptions of 100 function points. I selected Java. We put in a labor rate of $60 an hour, all nominal settings. We hit enter and it comes back with our schedule, our effort, and our cost. So let's compare. Well, using our analogy versus the Kokomo 2 results, ended up with a variance of about 14.4 in terms of effort, about 13.7 variance in terms of cost, and about between 5 and 16 in terms of schedule. So that's a really good analogy. We could do this very quickly and come out with a very quick ROM that we could then take back to our management and say, here's the traceability, all the steps we went through, and here's what we think it's going to cost. Here's the amount of time we think it's going to take. Dan, you want to take over the conclusions?
Sure, Carol. So, going through this example, what we've discussed is the ability to, we've displayed the ability to develop a reasonably defensible, high-level ROM estimate using only the functionality described in a conceptual operations document. We're using simple function points. You can use standard IFPUG function points, but you won't have that level of detail, so it's probably not worth the additional effort to try and just assume everything's average complexity or something like that. And, you want to make sure that if you're in a situation where you don't have experienced function point analysts, that you do use simple function points. And that, of course, whatever the business need is you're fulfilling is that ROM estimate is an acceptable deliverable on that. And if you are looking to, if you don't have any data that locally that you're collecting, now's the best time to start doing that. And if you're trying to develop a metrics program, start simple. Use count IFPUG function points for programs that you've done. Capture your effort, your actual effort, cost, and schedule, and then use that to baseline your productivity factors and other contextual data so that you can develop more rigorous analogous ROMs as you go forward. So with that, we conclude, and are there any questions?